Thank you very much for coming to NJIT. Right now, it's my great pleasure to introduce the Newark College of Engineering Dean Moshe Kem. Dean Kem joined NJIT in September 2014. He earned his PhD and MS from Drexel University and his BS from Tel Aviv University, all in electrical engineering. He's a fellow of AIChE, which is like the electrical engineering equivalent of AIChE, and served as president and CEO of AIChE. His professional interests are in multi-sensor systems, data decision fusion, navigation and control. And it's my great pleasure to introduce the Dean as our opening speaker this morning. He really made this conference possible, so please pay attention to him and give him a round of applause. Thank you so much.
Thank you. Thank you, Dr. Voronov. Very pleased to be with you this morning. As Professor Voronov said, my name is Moshe Kem, and I'm an electrical engineer amongst all you chemical engineering mavens. I'm coming from Tel Aviv University and Drexel University, but most importantly, in the context of this meeting, I'm a long-time volunteer of IEEE, and I hope that you will become long-time volunteers of AIChE. The opportunities that IEEE has given me over the years were unparalleled, and in fact, one of the reasons why I'm here today as Dean is because of the fact that a group of professors from NJIT came to my office at Drexel and convinced me to come here, and the way they knew me was from the fact that they were volunteers of IEEE, and I was a volunteer of IEEE. So when I don't do Dean's work, I build robots. So you see here some of the robots that I built over the years. This is on the left top, there is a tank-like robot that we built for the Navy a couple of years ago with a variety of sensors for operating outdoors. There is a snake-like robot that you see here, and this was built primarily for rubble, for buildings that fell in an earthquake, other tragedies, and you try to see if you can traverse and maybe find out if there is life beneath. And you also see here a rocket. I have a license to fly these small rockets in several parks in South New Jersey and the Philadelphia area, but I'd like to tell you that in spite of my licenses, every time I try to do that, the police come and try to arrest me and my students. So we now do it inside the military base. We gave up on these licenses. NJIT, NCE, Newark College of Engineering. We are an engineering education powerhouse. There is a long-time debate between myself and the dean at Rutgers if they are bigger or we are bigger, but we are more or less the same size and the largest colleges of engineering in the state, and we provide education in almost all major engineering disciplines. Most importantly for this meeting, we have a program in addition to chemical engineering and materials engineering. We also have a program in pharmaceutical engineering, and it befits a public school in New Jersey to have one of those, given how much you have in New Jersey in terms of activities of the pharmaceutical industry. We have been created as a College of Engineering in 1919, so we are slightly more than 100 years, and in fact it was in 1919 that we had our first chemical engineering department. Having been around for so long, we better have something to show for it, right? And I'll just show you one thing that we have done, which I think is the most profound invention that came out of what used to be NCE, the Newark College of Engineering. That was the name of the whole school. Now we are part of NJIT, and this is the New Jersey knee. And the New Jersey knee, formerly known as the New Jersey low contact stress total knee replacement, is a knee replacement device. And in 1977, the first time you had one that you could actually use. You could actually install it in a human, and the human could just recover and continue to walk about. And the idea was to develop a certain movable bearing that resolved problems of stress-related wear. So these two individuals, one of them from the mechanical engineering department here, and one of them from a medical school across the street, developed this thing, and I can tell you that in terms of the impact, and this is something that we always tell ourselves and our students, this is why we are here, in terms of the human impact of it. Today, of course, the 1977 design is no longer in operation, but every design of a a replacement knee is a child of this design. And these individuals, by the way, lived many years to develop new versions of it. 800,000 people in the United States and hundreds of thousands outside of the United States are getting this every year, a tribute to engineering in the welfare of society. I'll tell you a little bit about what we are working on. We do a lot of work on transportation here. Transportation is a major focus. You can see here like an illustration that try to demonstrate how you can try to look at the environment, say at the highway, and understand what's on there. We are interested in enhancing goods and freight movement for domestic and international purposes. And we have great interest in ports, especially because of the fact that we have one here, and because of the fact that port operations still exhibit, there's a lot of opportunity there for improvement. And if you read your newspaper or saw your other media, you would know that there is a long line of vessels waiting in Los Angeles. And you'll also find that there is not a long line of vessels waiting in Newark. And there is a reason for that. And the reason has to do with the design. The design is such that the Newark airport is now capable of much more effective operation in terms of throughput, and we would like to think that we had a small part in that. You'll see here the list. We are the third largest, New York after Los Angeles and Long Beach, and we would like to maintain it like this and even improve it, and we are working with the port. As I said, that's one thing that we do. The other thing that we do is transportation planning, design, and operations. This is a dangerous thing to say because every time there is a log jam someplace in New Jersey, someone comes back to me and says, well, you guys have designed that, right? Well, no, we are doing our best to improve that. And we are doing a lot of work in modeling and trying to understand what to do. And you will find, by the way, that this is not trivial and this is not straightforward. For example, when there is congestion, there is always, people say, okay, let's widen the roads, let's get more roads. And actually, sometimes closing some roads and eliminating some gateways improve the flow of overall transportation. It's known as the Brussels paradox after the person who has seen it first, and it's been seen in New York a couple of weekends ago in a beautiful way. There was a parade, and certain streets were closed, and all over Manhattan the flow was better without these roads. So there's a lot of wisdom to it, and one of the tools that we are using now is drones. And we are working with the Department for Transportation of New Jersey, especially for situations where there was a report of an accident. And when you have a report of an accident, people call in, but you want to see what's happening. And you can send first rescuer there, but sometimes it's a waste of resources because it was false or not particularly serious. And a drone can very quickly tell you what is happening. So this is something that we are focusing on now. We are interested in also overall in a situation like that where we're able to look at a highway, we look and understand who's there, understand how fast they are moving, and use that in order to control the traffic in order to make it smoother. We are also very interested in weather forecast and transportation. In particular, there was an incident here in 2018. We are still working on it. It was like a very mild storm. It was a relatively mild storm when storms in the Northeast are concerned. And in spite of the fact that there was very little snow on the roads, the whole area, the whole state in southern New York were paralyzed. And we were trying since that day to understand what are the conditions and what do you need to know and what do you need to do in advance so that situations like that do not occur. There were like more than 1,000 crashes. I mean, we are not kidding in terms of the impact of that. And it really came from nowhere. It was not a big storm. It was a mild storm. And for some reason, this mild storm has paralyzed the state and all of southern New York. We are working on wireless communication in the environment for quite some time. Sometimes when you drive around, you see these ridiculous trees, right? I mean, like, what's different? Who's different in this picture, right? But what we are really interested in some situations is what to do, what is the technical solution to minimize the number of towers. And if you are in an area like southern New Jersey, southern New Jersey has the Pinelands National Reserve. It's really a beautiful and very large forest, 1.1 million acres. You may not, I mean, even if you are driving this area, sometimes you don't know that it is there, but I mean, pay attention to it, and this is a place that in the spring and summer is certainly worth a visit. And what we have done there was to work with the providers and others to find technical solutions such that the design that initially meant that you need to put 87 towers inside a forest ended up with 16. So we are working on this kind of problems. We have a group here that tortures cell phones. Basically, if you go there, you'll recoil. I mean, we are breaking them, we are hitting them with hammers, we are drowning them, and the idea is to make them more resilient. We do a lot of works for robots for logistics. This is not the pictures from here. This is a picture from one of Amazon's warehouses. But we have a group that works on this kind of automation, as well as drones for delivery. It's already happening, and it provides interesting challenges, both technical, of course, and non-technical. One of our expertise is swarms of drones, and I'm not going to do it now, but later I'll ask that the video will put up. We have a group that with Lockheed Martin is working on drones flying in information. So you have 3, 4, 5, 10 drones in the air. They're forming certain geometric shape, and they move to place in spite of gusts of winds. And we have been quite successful in that, and this has become an expertise of NJIT. More close to things that our chemical and environmental individuals do, we do a lot of work on protecting water. There are at NJIT, I think, 12 full-time faculty members who wake up in the morning thinking about water and going to sleep thinking about water. And we are working about drinking water treatment processes. One area which I find fascinating is trying to map where water is coming from. I was aware of this problem when one morning I woke up on Saturday and I heard on my machine that the municipality where I live is warning me that one of the reservoirs needs to be closed. So I ran to the tap, and I have my cell phone, and I calculated the flow. And about 2 hours later, the flow went down exactly to 1/3, which gave me a sense that there is another source. I spoke to the engineer of the municipality, and I asked him, how do we know which kind of water comes to my house from different resources? And after about 20 minutes, he admitted that he doesn't know, and nobody knows. And the person who owns my water bill is the person who owns the meter. I mean, but it's not clear whether I mean, we know where in general they are coming from, but exactly what goes where. So it raises the question how to map it. How to map it, and how to map it in a way that will be innocuous, right? You don't want to put radioactive material there. And how to do that without alarming the population, that even the innocuous thing that you do will not be considered immediately to be some kind of great conspiracy, and you'll start having demonstrations in front of City Hall. There is a group here that works on personalized medicine in many aspects. One of them that I find personally interesting because of the fact that I was nursing my father for a couple of years, was that he used to take eight different pills in the morning and 2 pills in the afternoon and 4 pills in the evening. And half of his day was just managing this thing and making sure that he didn't forget and make sure at 10 o'clock in the morning, did he take it or did he not take it? And so the idea is to go and make a single pill that have all the medicine that someone like who chronically has chronic disease and need to take, and make it such that everything is there, everything is time released with the right time constants, and you can have multiple doses of different medication, and they are nicely compartmentalized using polymers. Fascinating and important work. So you understand what we are doing. We are doing practical problems. We are doing difficult and challenging tasks. And we are trying to instill in our students the sense of the practical, the theory, making them aware of the state of the art, and give them hands-on and experiential treatment. One of our recent additions, and you'll be able to see it from here, is the makerspace. We have built a large makerspace. We think it is the largest academic makerspace on the East Coast. And here are all the dignitaries. They came just for a day, but we, of course, after that day, opened this for everybody. And it is a large facility. It's 20,000 square feet. And it is an amusement park for engineers. You can find there all manner of devices, from 3D printers that you are familiar with to 3D printers that you are not familiar with, that can do metal, that can do titanium. Admittedly, my titanium budget is somewhat limited, but we can do titanium. And you'll find there, here are some picture of it, CNC machines and a very powerful water jet. Everybody is allowed in if he or she takes the training, and you can work there. And if you want to do your own project, we usually will ask you to pay for the material, but that's it. We'll give you otherwise access, and we'll give you technical support. So this is like a small catalog of what you can find there, and these pictures does not give you a sense of the enormity of some of these machines. One of the things that we have done with the Makerspace, and we'll do again, is a drone competition. What we have done was to announce to the campus in a certain October that anybody who wants to study how to make drones can come and study how to make drones, as long as you committed to come once a week in the afternoon. We offered it twice. And it started in November, it culminated in 63 students arriving at the end and having a competition. We had the drones that they made in the Makerspace fly through hoops. You see the hoops on the left top. Was great fun. And if you survived, in other words, if your drone did not get stuck in one of the hoops or in the fence or disintegrated on the floor. So about half of them were able to go through this. Then we ask you to take a more delicate payload, and this is a payload of fresh eggs, and try to bring it through these hoops back in peace to the very end. As you can imagine, we had an omelet on the grass, but half of the students who passed the first part passed the second part, and whether you passed or not, you were a winner. You were a winner, and we are going to do it again. We are going to do it again and invite other schools to do that. So let me just close by saying that you will see here the logos and the competitions of almost every association. We are very strong on a relationship with associations. We believe that students need to be part of the professional association because they start their networking very early, because of the fact that it provides an opportunity for leadership. And I'll tell you one more secret, and that is that the curriculum that you study here and in your schools is to large extent controlled by AIChE. And the reason is that AIChE is one of the components of ABET, which is the organization that accredits the program that you study. So if you want to be powerful in this area, if you don't like your curriculum right now, you think it is outdated, or you have thoughts about it, get into action, become part of AIChE, be at one point maybe the representative of AIChE to ABET and make a change. So congratulations on being here. I look forward to see your achievements. I'll stay around to the extent that I can during the day. We are very glad that you are here, and we wish you all the best today in your competitions and other activities. Thank you.
All right, thank you, Dean Cam, so much for sponsoring the conference and for giving us this talk. Next, we have Nick Amoros, who is the AIChE president of the NJIT chapter. He'll say a few words.
Hello, everybody. I'm the AIChE president here at NJIT, and I just wanted to give a short speech just to welcome you guys to NJIT. Hopefully, you guys will check out all the events that we have planned. We worked really, really hard on it, so hopefully you guys will check it out. Currently, we're going to be having the poster competition, the chemi car, and our meeting that we have. So I wish you the best of luck to all the schools here that are participating and competing, and just welcome to NJIT, and if you guys have any questions, please let us know. Thank you.
All right, so basically the plan is, enjoy the food. If you have dietary restrictions, there are really nice looking meals that are kind of hidden in the corner, but they're there, so please pick them up. We have a career fair here in the lobby. We'll have the poster presentations also in the lobby, so the career fair, you kind of go straight. Poster presentations, you go straight and take a left. And here we'll be having oral presentations. And this will go on until lunch. Then we come back here, meet for lunch. We have another keynote speaker. Then we'll have workshops here after lunch and the chemi car competition, we're all excited about that. So, yeah, so just enjoy. Thank you.